In today's video, we're going to talk about the Kaplan Meier test. This is a survival analysis, and by survival, we mean time to a discrete event. In this particular case, we have a database that is a pediatric database, actually neonates in an ED, neonatal intensive care unit setting. And our variables are the patient's ID, whether or not they were receiving surfactant, which is a drug that supports lung function. It keeps the lungs from collapsing in these little preemie babies. On days refers to the amount of time that they're on oxygen. So the question is, do children or neonates that are receiving surfactant, do they stay on oxygen more or less time than not? So it's better to get off oxygen as soon as you can. And then the sensor column, we say that an observation is censored if well, actually it's 0 if it's censored. 1 means that this child, for example, was off oxygen in 306 days. This child was stopped being followed at 310 days. So we don't know if he had oxygen after that. He could be off for a number of it could be censored for a number of reasons. One is he died, but the other is the study ended, and it just ended after he'd been there for 310 days. All right. So in SPSS, the way we do this is we go to Analyze, and then there is a set of survival programs. There are life tables. There is the Kaplan Meier curves, or Kaplan Meier table, which we're going to talk about today. Cox regression, which we'll talk about in the next video, and Cox with time description that with time-dependent covariance. That is that you're going along and you're measuring a certain, if you were in this case, for example, one of the variables might be the dose of surfactant. So it may change, go up and down over time, and that is a variable that's added. In this case, it's the same treatment, considered just you're either on surfactant or not during the duration of the time you're on oxygen, or during the duration of time you're followed. So let's go to our Kaplan Meier. And let me reset this. So surfactant is our factor that we're testing. Days on oxygen is the time until they've stopped oxygen. So everybody is on oxygen at the beginning, and then it's the time until they stop. Status refers to when they stopped, and we need to put in an event for that, so we're going to say 1. So they're on oxygen until that particular day occurs, days on oxygen. So the number that's referred to, this on days, is the number of days till either they're gone off oxygen or the subject has stopped being followed. Now we're going to want to compare the factors, and the comparison we're going to do is the log rank statistic. There are others, Breslow and Turanware, that are basically cover different times of when the curves are different. So you can look at that and get some information there. Let's see. Okay, log rank is a test for comparing equality of survival. All points are weighted equally. Breslow, the time points are weighted by the number of cases at the number of points that are weighted. So, and Turonware is they're weighted by the square root of the number of cases at risk at each time point. So at the beginning there are more people, and it's a little bit different. We just use the log rank usually as the simplest, most readily known of the variable of the tests. We don't have any strata. Say we had boys and girls, we could set that up as a strata and then pool over it. And then under options, this comes up and it calculates the survival table where, I mean, you can do that. It creates, well, we'll keep it in there for now. I don't usually do this one. It also gives you the mean and the median of the survival. Now, the median is probably the most important time point. The mean is affected, of course, by censored statistics. You lose the high end of the points. Now, the other thing we want to do is look at the survival curve. And so survival, everybody starts out at the top. This is a percentage plot, and it goes from 0 to 1. And everybody is 100% surviving at the beginning, and then the curve goes down. 1 minus survival means the time that they go off oxygen in this case, or death rate in another case. It starts at 0 and goes up over time. It's just a preference. They're exactly the same thing, just whether you want to see your curve go up or down. So we'll click on survival, continue. We can save the survival or the hazard ratios. A hazard ratio is the probability of surviving at a particular point. Let's go ahead and click on both survival and hazard so we can take a look at that. Okay, so here is our results. It says we have 43 people without surfactant and 35 with. There were not that many censored points, 5 altogether. And here's our table. So this says at time 5 days, it just gives the cumulative events. It doesn't, oh, this is no surfactant. So the first surfactant, the first kid went off surfactant at 5 days, or the first kid that went off oxygen was at 5 days with no surfactant. First kid that went off oxygen on the was at 14 days. And then here are the means and medians. Again, when we talk about means, we have to realize that the censored data, now there wasn't a lot of censored data, so it's not too negative, but you generally, when you have censored data, you're getting rid of big numbers that will make the mean get bigger. So, for example, the median was 107, and the estimate was 241. Now, if all the data were there, that could be higher or lower, but it shows kind of a real differential. In this case, for surfactant, it was 134 versus 71. I generally report the median. I just think it represents the distribution a little bit better. We can see that the overall comparison for the log rank is that it is a chi-square. It takes actually each of these observations, looks, it combines the no surfactant, kind of gives you, like in chi-square analysis, it gives you an expected value and an observed value, and it looks at observed minus expected over the variation, and it sums across all those total points. Actually, it multiplies them all, but you end up with a chi-square. And here is a plot. Now, in this plot, we have days on oxygen. We have the cumulative survival. So it starts with everybody is on oxygen. And then if you are getting surfactant, that's the red line, your oxygen is less required much quicker. So kids that don't get surfactant have to rely on oxygen for a lot longer. So that's it. That's the Kaplan Meier. In this case, it's pretty clear that kids on surfactant don't use oxygen for long, and the results were significant.